services, and if there is any unexpected traffic, then you can secure that traffic, like you can blacklist that IP, something like that. So yeah, so that are all the tools, open source tools that you can look for that was introduced over time. But these are mostly on the infrastructure side. There is nothing that can help you to monitor applications that you are running inside your Kubernetes cluster. So to explain the gap that have between the tools out there and the demand, I have taken this example setup. So let's say you have a Kubernetes cluster and you are running a bunch of services inside it, Python service, JavaScript, a lot of different languages, and they are all communicating with each other. And let's say you have exposed one of your service to the external world, so you can access your Python service via Chrome. And you want to see a flame graph like this, like you want to identify like which service is taking the most time out of your traffic. So let's say you have a shopping website like Amazon and Flipkart, and you open a page and it's taking a while to load up. And inside the Kubernetes you have like 5, 6 or maybe 50 to 60 services, and you don't know what is the bottleneck of for the slowness. So you want to see a flame graph like this, like you can identify, okay, 200 milliseconds taken by this particular service, 300 milliseconds taken by this particular service. So tools were not, the infrastructure monitoring tools cannot directly help you with something like this. So for getting this kind of flame graph, which is usually called distributed tracing in the world of observability, there is a popular tool called OpenTelemetry. So how many of you have already heard or used OpenTelemetry out here? Raise your hands. Okay. Okay, very few. So I'll take 2 minutes to introduce what OpenTelemetry is. So OpenTelemetry is also a community who have provided a bunch of tools. They have SDKs for all the languages, like for Node.js, they have NPM packages. For Python, they have PYBA packages, which you install in your application, and what they will do is they will create this kind of details for you, like what are your services and function, and how much time they are taking. So that is what OpenTelemetry do. And there are two approaches how you can build this kind of graph. One is the manual approach and one is the auto instrumentation. So we will go into both of them one by one. So in manual instrumentation, what happens is, I'm taking the example of Python here. How many Python developers? Okay, a few. How many Golang developers? Okay, yeah, our team is Golang. Okay. Yeah, so I'm taking, this is just one screen, I'm taking example of Python application. So if you want to build that kind of flame graph, like how much time is taken by your application, you will have to add like this 20 lines of code in your application, and you will have to again build your Docker image and put it into the Kubernetes. So that will take a bit of time, and let's say if you are a bigger enterprise and you have hundreds and thousands of services running, this will be pretty hectic to add this many code blocks in your services, and enterprises don't love at all to add some external code in their application, because we talk to many people day to day, and they are just like, tell me something that I don't have to touch my code and it is instrumented. It's really tough, but there are tools out there which can do this thing for you. So let's discuss about it. So the solution which OpenTelemetry community came up is called OpenTelemetry Operator. So what you have to do as a DevOps or developer to use this tool is, in your cluster, you just install the OpenTelemetry Operator Helm chart. So let's say you have done it. Now on its own it will do nothing, it will just sit there. What is the next step that you will have to do? Let's say you want to monitor your Python application, so you just go to your Python deployment file. Maybe it's not visible to all of you guys, so I'll just explain. So just go to your deployment file and just add one annotation that I want to monitor this particular application with OpenTelemetry. So once you add that annotation, the OpenTelemetry operator will automatically keep a watch on that deployment. And what will happen is, in the deployment itself, I am not adding any init container. I just have a single container which is running my application. But what OpenTelemetry operator will do, whenever a pod will be created, it will inject an init container forcefully. and that init container will add the code that we were seeing a few slides back. So it will add this 20 lines of code for you, and you will not have to add it manually. And another benefit of it is, let's say in your Python application you are running, connecting with any MySQL database or any server, like in Node.js you have Express server. So with auto instrumentation, what happens is they detect these small libraries that are there in your projects, and they also instrument that part as well. So you don't have to worry about anything at all on the code side. You just have to add one annotation, and OpenTelemetry Operator will take care of the instrumentation. So yeah, it will add the init container to each of your application, and it will also add one OpenTelemetry collector inside your Kubernetes cluster. So all the applications that are running inside your cluster will send data to that OpenTelemetry collector, and then you can forward that data to any observability backend, like you can send it to